Hello, everybody. Welcome back. Today, we are going to be talking about vertical and horizontal asymptotes once again. This time, we're going to show them with graphing, which is something we hadn't done previously. Previously, we just talked about where are these horizontal and vertical asymptotes, right? How can we identify them? But in this case, when we have to graph them, we not only need to figure out where the asymptotes are, but we also need to find the behavior around those asymptotes using limits. And that's something that we didn't previously do, but that we will do now. So I'm going to give an example for number one first, and then we'll move on to other examples in the future. Okay, so first things first, we have to identify the asymptotes, so that's the exact same steps we used in the previous video. So for the function y equals 4 minus 2x over x minus 3, determine all the possible asymptotes and sketch the function. So let's first ask ourselves, are there any oblique asymptotes? No, because the degree of the numerator is not exactly one higher than the degree of the denominator. Both degrees are the same. What about a horizontal asymptote? There is one. And because the degree of the numerator and the degree of the denominator are both 1, it's just the coefficient of these, right? So it's just going to be -2, which is the coefficient of the highest degree on the top, over 1, right? And so the horizontal asymptote is y equals to -2. Now, what about the vertical asymptote? Just a reminder, the vertical asymptotes occur when the denominator is 0. So when would the denominator be 0? When x equals to 3. So there we go. If this was a question from our last day, we would be done now. We would say, there we go, we finished, we're going to move on. But now we actually have to graph this. So first thing I'm going to do to graph this is I'm going to draw my asymptotes just in dotted lines. Maybe I'll do it in a different color just so it's more visible to everyone. So there's -2, y equals -2, and x equals to 3. So there we go. There's where our asymptotes are. Okay, so now what I need to know is what our end behavior is at this function at the vertical asymptote, and that will help us out. So let's do it. Let's do that. I need to figure out what is the limit as x approaches 3 from the left. 4 minus 2x over x minus 3. Okay, so let's figure out what is this. Well, we're approaching 3 from the left. So what is this going to be at something like that's really, really close to 3, but not quite 3, right? Because we're approaching from the left. So what about like 2.99? What would that be here in that situation? Well, that's going to be something positive, right? What about 2.999? Something even further positive. Basically, we're approaching infinity here, is what I'm getting at. So we are approaching infinity. So that means as we approach 3 from here, we're going up to infinity for this one. And we'll come down to approach this asymptote here. Okay. Next, let's figure out the limit as x approaches 3 from the right. What would this be then? Well, this is going to go to negative infinity, right? If I put in 3.1 here, then I'm going to have something negative. If I put 3.001, something even more negative, and so on. So we're approaching here. We're going this way this time. We're going to negative infinity. And so there we go. There we have it. Now, if you wanted to do an even more accurate graph, there are a couple other things we could find, like we could find the x-intercept and the y-intercept just by plugging in the values. I am not too worried about that personally, but that is something else we could do to find some more exact values. But the purpose here is just to sketch, and the main thing in the sketch that I am looking for is to make sure that the not the end behaviors, the behavior around the asymptotes is correct. So to make sure that this function here, that it's going up and approaching infinity, right? That we're approaching infinity here, and that we're approaching negative infinity here for this part. So those are the two main things that I'm looking for. And also, of course, that the asymptotes are drawn accurately. So here we have an asymptote at y equals -2. And then here we have an asymptote at x equals to 3. So to make sure the asymptotes are drawn correctly and that they are found correctly as well. Because if they're not found correctly, then there's no way they're going to be drawn correctly, or almost no way. Okay. The next one says for the function y equals 2 x squared plus 1 over x minus 1 x plus 2, determine all possible asymptotes and sketch the function. All right, so let's give that one a try. Let's first find all the possible asymptotes because we'll need to do that in order to sketch this function. So first things first, what's the degree of the function, right? Of the numerator and the denominator? Well, the degree is the same, right? If we were to expand this, on the bottom we would get x squared, and over here it's x squared as well. So the degrees are the same. So therefore, there are no oblique asymptotes, and the horizontal asymptote would just be the coefficients. Now, if we were to expand this, we would have a coefficient of 2 with the x squared on the top, right? And we would have a coefficient of just 1x squared on the bottom if we were to fully expand. I'm not going to fully expand here. I'm just going to demonstrate my knowledge that if we did fully expand, that's what we would get. So that's what I'm going to put there. Good. Next, let's move to the vertical asymptote. So x squared plus 1, don't get it confused with x squared minus 1. This is not a difference of squares. This is a sum of squares, and a sum of squares cannot be factored, right? And so both of these would have to be vertical asymptotes. So we have x equals 1 and x equals 2 minus 2, right? Awesome. Okay. So what do we need to do next? I'm next going to go ahead and draw these asymptotes. So we have y equals to 2, 1, 2, do, 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 do. We have x is 1, and also x equals -2. So I'm going to draw all the asymptotes. So that's all of them. They're all drawn. All right, so now what I need to do is I'm going to find the limit as x approaches 2 from the left, or sorry, x approaches -2, right? The first vertical asymptote from the left. And also limit as x approaches -2 from the right. I also need to find the limit as x approaches 1 from the left, and also the limit as x approaches 1 from the right. Okay? So we have 2 x squared plus 1, x plus 2, x minus 1. I'm just going to copy that down here for all the steps, and we're going to figure out what's what. All right, there we go. So for our first one, as x approaches -2 from the left, let's just think about it, try to contextualize. What if we had -2.01, so something a little bit more left than -2? Well, if we had that, we would have something positive on the bottom, right? Two negatives would make a positive. And then on the top, we would have something positive. So this one's going to be going to positive infinity. And likewise, the one on this next one is going to go to negative infinity because we will still have something positive on the top in the numerator, but we will now have something negative in the denominator. And so it's swapped there. And then we can do the same method for this one here. What if we plug in something a little bit less than 1? So 0.99. In this situation, we would have negative infinity, right? We'd have something negative, so it's going to go to negative infinity. And here we would get something going to positive infinity like that. Awesome. So now I'm going to draw my graph. I'm going to say, well, we said that it's going to negative infinity here and negative infinity there, right? This one and this one told us that. This one tells us that we're going to positive infinity up here as we approach the x equals to minus 2 line. And then this last one here tells us that we're approaching positive infinity over there as well. So there we go. Amazing. We did it. Okay. Let's do one more example and then we will call it a day. This one says, for the function y is equal to x squared plus 4 over x plus 1, determine all possible asymptotes and sketch the function. So first things first, we know that there's no horizontal asymptote. No horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. Now, what about vertical asymptotes? Well, yes, there is a vertical asymptote at x equals to negative 1 because when x is equal to negative 1, then that means that when x is equal to negative 1, we'll have 0 in the denominator, so we know that one. Now, the numerator is exactly 1 degree higher than the denominator, so what we need to do to find the oblique asymptote is we need to divide this. So let's use our long division that we know so well and figure it out that way. Okay, so let's see, x goes into x squared x times, so that's going to give us x squared plus x. And then when we subtract, we're actually going to subtract from 0, right? We have plus 0x here. So we're going to have minus x plus 4. How many times does x go into minus x? Well, minus 1 times. So that's going to give us negative x minus 1. We're going to subtract those. And we are going to get 5 is our remainder. So therefore, our oblique asymptote is going to be y equals x minus 1, right? And this is just an equation of a line. So I'm going to draw that line. It's going to be this line right here. And then I'm going to draw my vertical asymptote as well, which is going to be right here, like that. Now let's figure out how to draw the rest of the graph now. I need to find the limit, the right-hand limit, as we approach our vertical asymptote, and the left-hand limit. Okay? So let's see, what would our left-hand limit be? That would be negative 1.01, which would give us something positive on the top and something negative on the bottom, so negative infinity there. And then over here, likewise, we would say that it must be positive. It's approaching positive infinity because if we choose something like negative 0.99, something slight to the slight right of this, then we are going to end up with positive for both, and we're going to end up going to infinity. So let's draw that in. We're going to infinity this way, and then negative infinity over here. And there we have it. That's everything. All right, well, next time we'll be talking about concavity and Poisson flexion, but until then.